Welcome colleagues. In today's session we are going to start one of our main topics we have in EGM 211, which is engineering mathematics for second year first semester. And that main topic which we are about to start today is conic sections. It's conic sections. This is the main topic we are starting. Now our main focus for today will be one of the subtopics which are found in this topic. There are four main subtopics, of which we have the circle. We have the circle and its properties, including calculation. There is the parabola. We have the hyperbola. And then lastly we are going to look at the ellipse. But for today our main focus will be on the parabola. We're going to look at the parabola. We need to find the equations for the parabola. We need to look at least at one question on how we are going to solve for the parabola, and also some key important words to do with the parabola. So let's dive in. So for today our focus is the parabola. This is our focus for today. Our focus for today is the parabola. So the first thing you need to know about the parabola is there are three keywords which I would want you to know. This one, the first thing we need to know is there is the shifted version of the parabola, and the one which is not shifted. So for today we'll look at the one which is not shifted. So the first things which you will be needed to be identifying on the parabola is, one, there is the focus. The focus, we can represent it with capital F, and the coordinates for the focus, they can either be 0, P or P, 0. These are the coordinates we have. And you can also have a situation when your P is negative. You understand as we go on. So this is the focus, the first thing we need to have. And the other one is the dielectrics. Is the dielectrics. So for the dielectrics, its coordinate will be y equal to negative p. This is the point, the dielectrics, which you will see when we draw the diagram form of the parabola. So we have the dielectrics and we have the focus. So what it means is, once you find the focus, you are going to get that value for the focus. Let's say the focus is equal to 2. What it means, the dielectrics will be what? Will be negative 2. If the focus was negative 2, the dielectrics will be what? The dielectrics will be 2. Because we are just introducing a negative sign. We're just introducing a negative sign to the what? To the focus. So whatever your focus was, if your focus was 2 like this, your dielectrics will be what? Negative 2. If your focus was negative 2, your dielectrics will be what? Will be 2. That's how it works. That's how we are going to be moving, I guess, and hope that point is grasped. So now, since I was saying that there is the shifted version and the unshifted, so for the shifted version, it will be centered at our coordinates 0, 0. The one which is not shifted, will be centered at 0, 0. So it means the one that is shifted will be centered at any random point, which is a, B. It can be 2, 4, it can be 2, 2 or 1, 1. that's the one which is shifted. But for today, we are saying our focus is for the one which is what? Not shifted, which is centered at 0, 0. So now let's go on and try to draw the parabola. So for the parabola, first let's draw our line of axis. So we have the y coordinate, we have the y axis, we have the y axis and the x axis. The x is here and the y is the one that goes up. So our coordinates here at the center, it's 0, 0, 0. So let me even just write it here. So it's 0, 0. So this is where our parabola is going to start from. So we are going to write the first form of the parabola, of which we know, we learned that even in first year, that y equals to x squared. We know that this is a parabola, and this parabola will look like this. So now we're just going to introduce very simple additions to this equation. So the simple additions that we are going to include or put, instead of just having, we were having y equals to x squared in first year. Now what we'll be having, instead of we'll be having y equal to 4p x squared. So now, we'll be having 4py equal to x squared. This is what we should have. Yes. So instead of having y equals to x squared, we are going to have 4py equals to what? X squared. So this is just the little addition which you have. Instead of having this, but this and this, they're just the same. It's just that this, we introduced new variables and the number which is 4. The p stands for the focus, as we were discussing here. The p stands for the focus, the coordinate of the focus. So this is what we are going to have in this form. So it means now that y, which is the coordinate for the directrix, is equals to negative p. Since the focus is p, y is equals to what? Negative p. So let's say we have our focus here. It means the directrix will be somewhere here. One key thing which you need to know and understand is the distance from the coordinate, the starting coordinate of the parabola, which is here. From here, going up to the focus and going down to the directrix, it is the same distance. From the vertex, this point is also called the what? The vertex. So from the vertex to the focus, and from the vertex to the directrix, it is the same distance. It covers the same distance from the vertex to the focus and from the vertex to the directrix. You have to cover the same distance. So that is one thing which you need to know and understand. So let's try now. Let's say we determined that this is the focus, and we can see clearly that that's the y-axis. So it means x is equals to 0. So x at that point is 0, but we know that y is equals to the focus, which is p. So that are the coordinates which we are having for the focus. So we are going to introduce an arbitrary point here on the curve. This point is going to connect the focus and the directrix. So let me just clear up the space so that it makes more sense. So let's do this. So we had the y-axis and the x-axis. We had our parabola, then we had the directrix here. So from the directrix, so those were the coordinates. We introduce an arbitrary point here, which will be connecting the directrix and the focus. So now we can see clearly now that this point, it is an arbitrary point on the parabola, the curve of the parabola. Then that point has an x coordinate and a y coordinate. It has an x coordinate and a y coordinate. That is one thing which can be Now, one thing which we will need to know and determine is this point here. This point which is there. So that point is the point for the what? For the directrix. So for the directrix, since the focus there it's P, the directrix it will be what? Negative P. And now is X at this point 0, or it is a point? It can be determined. It can be determined. So X is something. It's not 0 like it was there when it was at the y-axis, but now it is between a space between the y-axis and the x-axis. So X can also be determined. So now we have this point for the directrix. We have this point, an arbitrary point on the curve. Then we have the point for the focus. Now we'll use these points to come up with this equation. We'll use the points which we have to come up with this equation. So how are we going to do it? We're going to use the distance formulas. So the distance from the focus, which is F, capital F, the distance from the focus to this arbitrary point here, we are going to take it into consideration. From F to an arbitrary point, we are going to set it equal to the distance, because they are equal to, remember what I said, the distance from at this arbitrary point to the directrix. So we are going to set them equal to, for us to come up with that equation. Now remember, what was the equations we used for us to find the distance between two points in our axes? So which formula did we use as the distance formula? Remember, D was set equal to the square root of x minus x1 squared. So let me say this is x2 minus x1 squared plus this square root, let's elongate it, y2 minus y1 squared. So this was our distance formula. This was the distance formula. So we are going to apply it both sides using the coordinates which we have there. So we are going to apply the distance formula, both sides, for this part and for this part, since they are equal to each other. So we are going to use our coordinates to see, for us to come up with this. So let's just clear up for more space. Let's just clear up so that we get more space. So now, since we have ascertained our distance formula, we know our distance formula, let's start with these points. We are starting with this coordinate. The first one, it is 0, P for the focus. This, we are merging it with the point for the arbitrary point. So which was x, y. So now let's use the distance formula for these two. And afterwards, we'll use the distance formula for when this point, arbitrary point, merges with the point for the directrix, which is x, negative p, while them being set equal to each other. So for the first part, we are having x here. For the first part, we are seeing that x. So let's take x. We're taking x. This will be our x2 and y1. So this one here, the arbitrary point. Our arbitrary point, that's where we're going to refer to as our x2 and y2. So let's say x2. So this is x2. So x minus, we're having 0 as x1, 0 squared. Then say less, open bracket, y2, which is y, minus p squared. Then we are setting this equal to, when we are using the distance formula for this set, equal to the square root of x. Here we're having our x1 as x minus x squared, less, and pardon me, here it's supposed to be a positive. Here it's supposed to be a positive. For our distance formula, here in between it's supposed to be a positive. So now we're having our y2 as y. So we're having y minus negative p. So since it will be minus minus, we are going to have what? A positive. So here we're having plus p squared over the square root. Now let's try to observe this. You will see that this will be 0. So for the right hand side, we are just going to have the square root of y plus p squared. In the end, the squared will cancel with the what? Square root. So on the right hand side, we are just having y plus what? Plus p. Now our main focus now will shift on the left hand side. What are we having for the left hand side? We are seeing this is x minus 0, which is just the same as x squared, isn't it? Then plus y minus p squared. This is what we are having currently. So now this, the square root of x squared plus y minus p squared is equivalent to y plus p. So now here, how can you collect the like terms? Since this side there is a square root, it is very hard for you to do that. So what you just need to do, for you to remove the square root, you have to square both sides. So you square this side and then you square this side. So here on the left hand side, we are just going to have x squared plus y minus p squared equal to y plus p squared. So now you can even collect the like terms after expanding. So we expand this and we are going to expand this side. So in the end, we collect the like terms so that we see if you are going to obtain our formula for the parabola. So let's go on and expand this side, the left hand side. So we're having x squared. So for expanding, since we are seeing y minus p, so we're having two brackets of y minus p. So we're having plus. So for you just to expand, you just have to say y minus p. So this is what you are having. So you are multiplying this. So the first part to be y multiplied with y and y multiplied with p. Then the second part to be p multiplied by y, then p multiplied by p. So let's go on. We are going to have x squared plus y multiplied by y, that's y squared. Then y multiplied by minus p, we are going to have minus yp. Minus p multiplied by y, we are going to have minus yp. Minus p multiplied by minus p, we are going to have positive p squared. So this is what we have for the left hand side. So we have to go to the right hand side. The right hand side, we just had the square root of p of y plus p. So it means we are multiplying y plus p multiplied by y plus p. So we are just going to use the same thing. So we are equating this equal to y multiplied by y, which is y squared, y multiplied by p, which will be plus yp. Then this p multiplied by y, it will be plus yp. Then p multiplied by p, it will be plus p squared. So now let's try to observe what we have gotten. So you can see that there's a y squared here and there's a y squared here, and they are carrying they are carrying both the same sign. So when the other one is when you subtract them both sides, they will cancel each other. In the other way around, in our primary, they say that if you take one to the other side, to cancel the other. So this and this will cancel itself. The other thing you are seeing is there is a p squared here and there is a p squared here. But if it was minus p plus p, then you know that we are going to add. But now they are cancelling each other. Now what is remaining? On this side we are having yp plus yp. So this will be 2yp on this side. Then on the left hand side, what are we having? We're having x squared. There is x squared here. So we're having x squared. Then afterwards we're having minus yp, which is minus 2yp. This is what we have. So we can just add this both sides for it to be cancelled here. on the left side. So we are adding it both sides. So in the end, what are you having? You're having x squared equal to 4py. So we have managed to obtain the common relationship or the common formula for the parabola. So this is the formula for the parabola. And for you, one thing you need to understand is, so this will be determined by where your focus will be. So you can be given any equation. Let's say they can say y is equal to negative half x squared. So they can just give you this random equation. So what you just need is, you need this to match up with this. So the first thing is, you're going to leave x squared alone on one side. Then afterwards, you're going to match up what you're going to have. So from here, what were you going to do? You're just going to say x squared is equal to, we're going to multiply both sides by negative and by 2 so that we cancel the half. So we're just going to have negative 2y. So we can see that this is almost now similar with that. So now what we're just going to need to identify is p, which is our focus. So we're going to set 4p equal to what? Negative 2, which is here, which is matching with that. So we will understand that our focus in here is equals to negative half. So now if your focus is negative half, it means that your directrix is equals to what? Is equals to half. So that's what you have. If your focus is negative half, your directrix is half. And you know that when the parabola is like this, the focus is here. So it means even if the parabola is like this, the focus is where? Is here. The focus is enclosed around, enclosed inside the parabola. So your focus will determine where your parabola is facing. Your focus will determine where your parabola is facing. Is it facing to the on top or on the bottom, or is it facing on the left side or the right side? Now if it's facing on the left side or right side, or it's facing on top or on the bottom, again there is another thing which I'll need to explain. So now here we have identified that our focus is negative half, then our directrix is half. Now we have to identify where our parabola will be facing. So let me write these diagrams of parabola. There is this, the first one. There is this, the second one. We have this. Then the last one. Now, how are you going to know where if your parabola is supposed to look like this, or like this? So for the first two, the equation has to look like this. This is what you need to have as your equation. Then for the last two, your equation have to look like this. So if you have y squared, it means your parabola will be the vertex of your parabola will be aligned on the x-axis. If you are having x squared, it means your vertex will be aligned on the y squared. So it will be aligned on the y-axis. So that's how we are going to identify. Now the direction on which it will be facing, now it will be determined by your focus. If your focus is negative, it means your focus will be here, so it will look downwards. If your focus is positive, it means your focus will be here, so it will look upwards. Then we can come here to say if your focus is positive, it will look on the right side. If your focus is negative, it will look on the left side. That's how we are going to determine. So here on our question which I just put on, we found that our focus was, first let's look at the equation. The equation looked like this, so it was x squared. So x squared, we have seen that x squared, it has to look like this or like this. Now let's check our focus. Is our focus negative for it to look down, or is our focus positive for it to look up? So we'll go on and check our focus. Oh, our focus is negative, so we know that our parabola must look what? Must look downwards. Now where is our focus? Our focus is here. This is where our focus is, and our focus is negative half. So our coordinates is 0, what? Negative half. Because negative here x is 0 and y is equals to what? Negative half. Then we have the directrix. Now the directrix is just the negative of the focus. So negative half, which is what? Which is just positive half. So the directrix here is just 1 over 2. So now in this short video I've shown you how to sketch. I've shown you how to find the formula for the parabola. I've shown you how to identify where it's looking or where it will be facing. So now I just want to leave you with 2 questions. I just want to leave you with 2 questions for you, which you should try and send in the group. So you should do it individually and submit as soon as you finish. So the first one is x is equal to 1 over 8 y squared. Then the second one which you'll be having is y is equals to 4 y is equals to 4x squared. So this is our first question and this is our second question. Then let me just put the last one. Let me just put the last question, which is x squared is equals to let's put 3 here. Then we are going to say y. So try solving these 3 questions and then submit. Thank you for your attention and time. Until next time, bye bye.